In this video, we're going to look at the queue data structure. And again, I probably shouldn't use the term data structure since we're not going to be looking at any particular underlying implementation. So if we're not looking at any underlying implementation and just talking about the operations associated with something, then we should be referring to it as an abstract data type and not as a data structure. But hopefully, since I make that distinction or that disclaimer at the beginning of the video, even though I use the term data structure, that you'll know the difference. So what's this queue all about? The queue is just what we call a FIFO data structure, and FIFO stands for first in, first out. So it just simply means that the first item that we add in to our queue is the first item that we would remove from our queue. And this is exactly opposite of what we had with the stack, which was a LIFO data structure. So it said that the last item that we added in was the first item that we removed from the stack. So the queue should be a very familiar structure to us. So it kind of models this idea of waiting in line. So if you've ever waited in line for something, then you really have a good idea conceptually of what a queue is all about. What we're going to talk about in this video is just simply the terminology associated with this queue abstract data type or queue data structure. So we'll say that maybe we're at an amusement park and we have a roller coaster ride. And right now we have some people that are currently riding this ride, and we have a line, and right now our line is empty. So we could say that our queue for this ride is currently empty. Or we could say the size of the queue is 0. And then all of a sudden we have a lady that comes up and she gets in line for this ride. We would say that this lady is now in-queued, or she has been pushed onto the queue. And I know pushing is not really a polite term when you talk about lines, but in terms of the data structure or the abstract data type, we would talk about the item being pushed onto the queue or in-queued. I kind of prefer the term in-queue because it kind of separates us from the idea of the stack, and we use the term push for stack. But push is often used as well for the queue data structure. So this woman here represents what we call the front of the queue or the head of the queue, and she also represents, since she's the only person in the queue, the tail or the back of the queue. So our queue now is of size 1, and this lady represents the front of the queue and also the back of the queue. And then we could have someone else. So maybe we have a gentleman that comes along and he's interested in riding the roller coaster as well, and we would say that he has now been in-queued. So this now changes the size of our queue from 1 to now 2. We have 2 people that have been in-queued, and this lady is now no longer the back of the queue. She's still the front of the queue, and we could also say she's the head of the queue. But this gentleman here is now the tail of the queue or the back of the queue. And then we could have maybe another person that comes along and he gets in-queued. So we did another in-queue operation here. And for whatever reason, he has a microphone. So maybe he's singing or talking to people on a loudspeaker. But he's been in-queued, and he now becomes the tail of the queue or the back of the queue. The lady here is still the front of the queue or the head of the queue. And this gentleman here really doesn't have, a specific name. He's just in the middle somewhere. So with the queue data structure, you'll usually have an operation that allows you to access the head or the front of the queue, and you'll have an operation that allows you to access the tail or the back of the queue. But you don't have any mechanism to be able to access anything in the middle of the queue. So let's add one more person to our queue. So we'll push on or in-queue one more person. And so we now have a queue that's of size 4. The lady is still at the front of the queue, and this gentleman here that we just in-queued is now at the tail of the queue. So what we've seen here is that every time that we do an in-queue operation, we in-queue the new thing at the end or at the tail or at the back. And that is a restriction or a constraint with the queue data structure, is that any item that we're in-queuing or adding on has to be added on to the tail. We cannot add something to the middle. We cannot add something to the front. It has to be added to the tail of the queue. So now that we have these 4 people in our queue, so we have a queue of size 4, let's look at doing the operation of removing someone from a queue, and that's what we call dequeuing. And dequeuing only occurs at the front or the head of the queue. So again, this is a first in, first out data structure. So the first person that was in the line here will be the first person that's dequeued. And we can imagine them being dequeued from this line and being able to get on the ride. So I'm going to say that this lady here is now being dequeued. So now that she's been dequeued, this gentleman here now becomes the head of the queue. So if there's more space on the ride for him to get on, then he can be DQ'd. So we can imagine him being DQ'd. Again, every time we do a DQ operation, it has to happen at the head of the queue. So now this gentleman here with the microphone is now at the front or the head of our queue. So that's pretty much what's going on with the queue in terms of the operations. Typically we can get to the front of the queue with a particular operation, we can get to the tail of the queue, we can do in-queuing, which occurs at the tail, we can do dequeuing, which occurs at the head, we can get the size, and we can also usually test for empty. So in terms of uses for the queue, certainly as we've seen here, we can simulate waiting lines. Typically you'll also find a lot of queue data structures within computer systems for buffering input and output type operations. So you can think about maybe a print queue. So if you have a network printer where you have multiple computers tied into that particular network printer, you may have lots of job submissions and they want to print those jobs out in maybe a first come first served basis or a first in first out basis. So those jobs would be queued up inside a memory buffer within that particular printer. And the same idea goes with keyboard strokes. So as we type on the keyboard, then there's a buffer there for that input to keep track of the keys that we pressed in the order that we pressed them. So we want to make sure that whenever these characters show up on the screen, they show up in the same order that we typed them out on the keyboard. So they would be inputted into a buffer, a FIFO buffer, a first in, first out buffer. And the same thing can be thought of with frames in a video as well. So that pretty much covers everything that I wanted to talk about for this queue data structure, at least from a conceptual standpoint. So hopefully you understand that the basic operations of in-queue, DQ, the front of the queue, the back of the queue, or the tail of the queue, and the head of the queue, and you have some sense of how the queue is used. So that's it for this video.